At GTC Taipei on May 31st, 2026, NVIDIA unveiled the ETH Zurich reference humanoid robot, the first open humanoid reference design, built with Unitree and Sharpa. It pairs a Unitree H2 Plus chassis, nearly 6 feet tall and 150 pounds, with Sharpa 5-finger hands and a Jetson AGX Thor module delivering 2070 FP4 TFLOPS. AI2, ETH Zurich, Stanford, and UC San Diego are already adopters. In the next few minutes, we cover what it is, how it works, and why it matters. Let us start with the core idea behind how to implement ETH Groot Humanoid. Here are the essentials of how to implement ETH Groot Humanoid in plain language, what it is, and why it was introduced. At GTC Taipei, NVIDIA announced the ETH Zurich reference humanoid robot for academic research, the first open humanoid reference design, built together with Unitree and Sharpa and aimed squarely at university labs and frontier robotics research. The reference build uses the Unitree H2 Plus chassis. NVIDIA states it stands nearly 6 feet tall, weighs about 150 pounds, and carries 31 degrees of freedom across the body for human-scale testing and experimentation. Sharpa wave tactile 5-finger hands add dexterous manipulation. According to NVIDIA, the hands contribute 22 degrees of freedom, bringing the full design to 75 degrees of freedom across the body and hands combined. The onboard brain is the Jetson AGX Thor, a Blackwell-class module. NVIDIA rates it at up to 2070 FP4 teraflops with a power envelope starting around 40 watts, handling reasoning and control directly on the robot. Now let us look at how to implement ETH Groot Humanoid matters in practice. Here is where how to implement ETH Groot Humanoid shows up in real products, teams, and decisions. The open ETH Zurich platform spans the full workflow: data collection, foundation model training, simulation, and policy deployment. We get hardware and software together, not just a chassis, so a lab can go from data to deployed behavior. NVIDIA says a reference workflow for the Unitree G1 is coming to GitHub and Hugging Face. We can start from open, published code rather than reinventing the pipeline, which lowers the barrier for research teams. Leading institutions, including AI2, ETH Zurich, the Stanford Robotics Center, and UC San Diego, are named adopters. We can treat their use as a signal that the platform is built for serious frontier research, not just demos. NVIDIA says the reference robot will be available from Unitree in late 2026. We should plan procurement, budgets, and lab integration around that window, so our team is ready when units ship. Let us recap the key takeaways on how to implement ETH Groot Humanoid and what to do next. The headline is that NVIDIA, with Unitree and Sharpa, delivered the first open humanoid reference design, unveiled at GTC Taipei on May 31st, 2026, and aimed at academic research labs. The body brings 31 degrees of freedom, and the Sharpa 5-finger hands add 22, which NVIDIA totals at 75 degrees of freedom across body and hand for dexterous, human-scale work. The compute is a Jetson AGX Thor Blackwell module rated up to 2070 FP4 teraflops, starting around 40 watts, running reasoning and control on the robot rather than in the cloud. The open ETH Zurich stack covers data, training, simulation, and deployment, with the Unitree G1 workflow heading to GitHub and Hugging Face, and the robot available from Unitree in late 2026. If we are building or planning a humanoid robotics program, the ETH Zurich reference design gives us an open chassis, brain, and software stack to start from in late 2026. We can begin learning the ETH Zurich workflow today. For more information, visit Standarity.com. See you in the next video.